What's up? What's good? What's happening? My apples and oranges. Let's dive into 3.1 with the Ready, Set, Go introduction. I hope you're having a great day. What's going to be discussed here with the Ready? Let's see. We're graphing linear and exponential functions. Doesn't it sound as if we've been doing this for a bit? It should. Just as a heads up, linear equations can take on this form, y equals mx plus b. Sometimes this b term, the y-intercept, is moved in front of mx, of course, where m is your slope. So be open to situations like that. Sometimes the y-intercept moves around a little bit. Exponential functions are in the form a times b to the x power, where a is our starting point, or starting value rather. B is considered our common ratio. And x is how many times we keep multiplying to get there, okay? So a lot of these problems should sound familiar, like something we've done before. In this case, we're being asked to name 3 points that lie on the graph. Does that sound good? Are you ready for this? Anyway, 1 point that's on this line I know is going to include the y-intercept, which is hanging out right here. So I know that if x is 0, the outcome there is 5. And I know that my slope is -2, which is saying that every time I add 1 in the x direction, it means that I'm going to be subtracting 2 in the y direction. And we could keep this pattern going. So I'll get 2 more points, or 1 more point. Next point would be when x is 2, the outcome from 3, what do you think that would be? Hopefully you're saying 1. All right, so we got some points here. It's all good. We're going to make this as best as we can. So let's make my, and this can be kind of tough to set up the axes, but it's nothing we can't handle. So let me do something like this. I'm going to make my x-axis go from here to here. Label this x. And I'm going to have my y-axis. Remember, I need to give some respect to the fact that 0, 5 is a point on there. So I'm going to have this, let's just put it through here, if possible, if it lets me. Technology, am I right? Okay, let's do this one more time. Let's have our y-axis cut through right here. And I'm going to be graphing out these points. So 0, 5 was my first point. So let's say that this is up on the y-axis here. And then I have a point 1, 3. And then I can also map out here and here. And I can just keep going. Draw a line between them, call it a day, move on with the world. Seems easy enough, right? So notice that getting the points was what I did first. I didn't just run in and say, yo, let me just start moving the line around. I care about it, but right now I'm really just focused on what points are going to definitely work. And it fell back on using the y-intercept and using the slope to make that happen. I should also note that this point would have been 2, -1. Okay, sound good for the first one? This first one's trying to deceive you, but what looks different about this equation? Hopefully you're saying it's linear. That's a big deal. But also the y-intercept's in front. But that shouldn't stop you because you can just scoot it on down here. And then you could just graph -3x plus 4. I'll leave the rest to you for that one. Take a look at this type of equation. I'm going to use, I'll use this color. That's fine. No, I'll use purple. How about that? Where this is, well, what do you think? Is this linear or geometric? Hopefully you're saying geometric, or as we called it in module 2, it's exponential. So this is going to be multiplying or dividing as it moves forward. I know that my starting term is 5. And so I'm going to actually scale this down a bit. So I know that if x was 0, the outcome would be 5 because 5 is my starting point. And then how do I go about getting the next few numbers? Hopefully you're saying multiplies by 3. So 5 times 3 gets you 15. Get one more point. 15 times 3 gets you 45. Staying alive. Okay. Well, I know that my starting point here, I'll make this 5. The next point should be 15, so I'm going to scale this by 5s. So when x is 1, the outcome's 15. Hopefully I can fit 45 on this too. If I keep this going, counting in 5s. Oh, check me out. When x is 2, the outcome's 45. Remember, this was my x-axis. This was my y-axis. Do my best to make this geometric, going up to infinity and beyond. Gonna share this screen real quick so make sure that you're paying attention. And then I'm gonna dive back into this. All right, so that should help you get through those first few problems. What's the set doing? The set, similar to our Desmos, is given some context for each graph, given match it to a descript or words for each graph given, should be a comma here, match it to the contextual description that fits best, then labeled independent and dependent in the axis with the proper variables. Okay. The amount of money in a savings account where regular deposits and some withdrawals are made. All right, so we have some money that's being given, some money comes in, so some money is added, some money is subtracted from the account, but we start with a little bit, which is cool. All right, so we're looking for something that goes up and down. Which do you think would work there? And remember, we have all these options. Hopefully you're saying that this looks as if it's going up, 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 but then goes down a little bit and then up again. So this would be similar to 10, where we could measure this as time and then how much money is in the account, because over time, sometimes it's going up, sometimes it's going down. Or, well, what do you think? Does that really work? You're about to fall for that. This is regular deposits and withdrawals are made. Well, actually, do I have all my options? I do. Yeah, I'm going to say that this one's it. All right. As far as the variables, independent and dependent, the amount of money is dependent. So the amount of money depends on the deposits and the withdrawals. So I would say that these are independent. Does that make sense? Hope it does. B, the temperature of the oven on the day that mom bakes several batches of cookies. Well, if we have several batches of cookies, it probably starts at some temperature, like maybe it's like, I don't know, 60 degrees, and it probably goes up to like 250, and then it may simmer back down. Then we have to make more, and then that just keeps going on and on and on. I would say that it's continuous because it keeps fluctuating. So I'd say that this goes with B because it keeps going up and then down, fluctuates there. The amount of gasoline on hand at the gas station before a tanker truck delivers more. Oh, sorry, I should also mention that the temperature is dependent. And what's independent? I guess the time is independent, or the batch of cookies. Yeah, it's kind of tough here. Batch of cookies is independent. That one's kind of a weird one. Amount of gasoline on hand at the gas station before the tanker truck delivers more. So ideally there should be a re-up at some point. So let's see if we can find one that has it going down. Because ideally this should keep going down before, and notice here it's before. Okay, so I would say that this is going to be C right here, where the amount of gasoline is dependent. And what's independent? I guess it's how much gas is being used. Or time. So I'd say that this is independent. Hope those help for those. Yeah, we'll do some here. Given the pair of graphs in each coordinate plane, create a list of similarities the two graphs share and a list of differences. Talking continuous, discrete, increasing, decreasing, linear, exponential, restrictions on domain or range. Similarities, well, they're both lines. That doesn't say much. I could say that they're decreasing because they both go down and to the right over time. They look as if they have a point in common, like right in here. So they have a common point. I would say that their domains are the same because they're using all real numbers, which I'll use as this. So all real numbers. What else? Differences. One's linear, meaning this one's linear. The other's exponential. For the linear one, that range is all real numbers because we're using a bunch of y coordinates, whereas the range for this is from 10 to negative infinity. It's kind of a cool thing to mention. What else? They're both continuous. So yeah, continuous we mentioned. We mentioned that they're both decreasing. We mentioned this. Range, yeah, okay, those are good. Next one I'll have you try on your own. For the go, we're finding the values that make the statement true. So this is 10x equals 100,000. Well, I know that if it's 10 to the first, it's just 10. I know that if it's 10 squared, that's 10 times 10, which is 100. So it's not quite the 100,000. If I do 10 to the third, that's 1,000. And then if I do 10 to the fourth, it's 10,000. 10 to the fifth. 10 to the fifth works. So what do you think our answer is going to be? Hopefully you're saying that x in this case should be 5. Because if 10 was taken to the fifth power, the outcome that x would have to be is 5. So we would say x is 5. For this, I'm going to balance both equations using what I call SADMAP. You might say, what is that? SADMAP, I'm going to be using subdition. That's a blooper. That's a good one. Subtraction or addition first, and then I'm going to multiply or divide, and then use exponents, and then parentheses. So I'm going to move my x terms to one of these sides. Where do you think x's would work better? If we move the 3x over here or 5x over here? Hopefully you're saying that subtracting 3x from here and here is the better move. And that moving, so what I'm going to give you the game plan. I'm going to move x's to the right, and I'm going to use the left side just for my numbers. So that means I would have to move the 21 over to here. 7 plus 21 is 28. 5x minus 3x is 2x. So our first step, use these two, we're done there. And now how can I go about solving for x? Well, we have 2 multiplying with x. So we have to undo multiplication using what operation? Hopefully you're saying division. So we're going to divide both sides by 2. 14 is equal to x. Is that all we had to do? Okay, yeah, that's it. 3 is similar, or sorry, 18 is similar to 14. 17 is on its own, not too bad. Most of these are just going to, you know what, I'll do a 2-step equation one. I'll do 17. So I have 5x minus 8 equals 37, and I'm still going to use SADMEP to make that happen. Not to be confused with PEMDAS. So I'm going to be using subtraction or addition most likely for this first part. I know that I want to isolate x. So I could probably move this -8 to the other side, but how could I do that? How can I move this -8 to the other side? Well, hopefully you're saying by adding. So my first step here is going to be using addition. So if I take that further, 5x is left. 37 plus 8 is going to be 45. Then what step can I do from here? Is it division or multiplication that I have to do next? Hopefully you're saying division. So I'm dividing both sides by 5. 5s can cancel. 45 divided by 5 is 9. X equals 9, and I'm done. I hope that this video was helpful. If this is the Ed puzzle, at some point I dropped a character in the video, so type in what character that is, and there might be a prize for you. I hope that you enjoyed this. I hope you have a great day. Let me know if you have any questions. Thanks.